Hello, everybody. Today we are going to talk about state machine. What is the machine? Machine is already I told you it has a vector curvature. Okay, any system which has a vector curvature, it is called a machine. Okay, vector curvature is called a machine. Okay, if it has got any kind of vector elements, immediately it is called a machine. Machines are usually built because of vector elements. Usually, force transfer, all these things happen because of machines. Okay, machines can be built on any structure. Okay, you can build it on plastic. You can build it on kind of. Other kinds of forms like iron, or you can build it on like aluminum or other thing. But what how the forces act on a particular system to make the machine work means, like if we take a motor or an electrical motor, or a ordinary motor, or a car engine or a bike engine, those kind of things. Okay, that is usually called a machine. And how those vector forces act in those machines. Okay, those are the kinds, that is why it's called a machine. Okay, that machine has got states. What are states? States means analysis of a particular vector diagram. Analysis of a particular vector diagram, like you can see it here, how those forces act in different directions. Okay, here we have the things, what is the state and other things. Okay, these are the kinds of things. Okay, state can be anything. Okay, whether it is a simple curved loop. Okay, immediately, so say for a tire you have a curved loop, and because it is a circular vector, it just keeps spinning that particular vector, and it is called a complete loop, or it is called finite. Okay, finite means no no that is the if it goes on a circular ring, it is called an infinite series. Okay, if it is not going on an infinite series, say you have a brake or something like that. Okay, so you apply brake, and the curvature takes a inward state, so that it comes to a point. The vector forces come to a point, then it is called a finite state machine. So you have to understand how the vector diagrams are there in order to understand what is the kind of finite state machine. Okay, how say if you have an algorithm and it reduces to zero, so that algorithm, if it reduces to zero, then it has got a finite state machine. If an algorithm is not reducing to zero, but it goes on for you're repeating the same kind of state sequences, like if it goes to 1, 2, 3, 5, and then 1, 2, 3, 5, 1, 2, 3, 5, that kind of particular loop is created, then it is called an infinite state machine. Okay, some state machines are like infinite state machine, and some particularly irrational state machines. Irrational state machines is like they never terminate, but they have got like root 2 for number theory. According to number theory, root 2 is an irrational number, so it has got a infinite state machine. Okay, you can never end those kind of machines, but it has got a different number kinds of predictions and other things, and it's quite random. So when you are running a particular, designing a particular car or something like that, it might be random state machine, in which case it will just break very fast. Okay, finite state machine will have some kind of finite state in which you can just judge where the machine is going to fail, and the failure is rectified, and you can easily find out where you have problem within a car or something like that. So that is called a finite state machine. Within a particular algorithm, there are different kinds of states. What is the state from one state to another state? What is the state of a machine? State of a machine is like if we have a tire or an engine or something like that. If it is spinning, then from one point to another point, if it is spun one full circle, or it has moved if the car has moved about 10 centimeters, because of the state of the particular thing, that particular state, from the initial position to the final position, what are the different states taken to stop. So you start a car, you go somewhere, you stop the car, so that full sequence is called a finite state. Finite means the program goes somewhere and then it starts ending on some place. So that is called a finite state machine. Non-finite state machine, you keep on running the car forever. That is called infinite state machine. Okay, so it is a kind of like state machine is switching from one state to another state kind of thing. Okay, from one position, one vector place to another vector place, or one logical sequence to another logical sequence. These are called logical sequences. Logical sequences are compressed to one particular thing and then switch to the network. If the logic is a cyclic kind of thing, then it's an infinite state machine. If it is kind of like infinite, and you can bring it to stop at a particular point, then it is called a finite state machine. So logical circles can have different kinds of state machines which you can run. Okay, this is called a finite state machine and an infinite state machine. Okay, why do we learn about finite state machine and infinite state machine? Just for convergence, divergence sequence. And while you are writing a protocol, it has to have some kind of convergence sequence. Then only the protocol will end. Okay, what is the protocol will end? Say if you want to the TCP connection, you open the TCP connection, you have done all the transfer, and you stop the TCP connection, close the connection. So once you do a close, it is actually ending the termination in the sequence. That kind of finite state machine. So that is why it is called a finite state machine. So that you have the file already transferred and you have an yes or no answer at the end. If you don't have an yes or no answer at the end, it means it is an infinite state machine. Okay, you can never judge within a particular set of time sequences are not very careless. Oh, okay. So how do you switch states? Switch state is say you are writing some kind of program or something like that. Okay, what is the switch state? Switching a state from one state to another state. What is the switching of the state? But from because switching elements like Cisco elements or all these things, they use switching state, or kind of they use state machines to switch from one state to another state. That state of a machine is like that switching point from one to another thing. Okay, that is why it is called a finite state machine. Okay, say if you have a tree structure from the top you pass down and you end on a particular sequence, then it is called a finite state machine. Usually tree structures are finite state machine. Why they are finite state machine? You can start from somewhere and end up in a particular sequence and to another place. The tree structures are usually kind of finite state machines. For non-tree circles or a loop kind of structures are infinite state machines. You can have star structure, you can have other kinds of structures, but still those kind of states of machine can change. Okay. So how to create states? How to create states? Say if you want to exchange something, okay, say you want to exchange a letter or something like that. Okay, first you say that I want that letter. So you that is your state. That is the first statement you made to get that letter from someone. Okay, so you say state one. State one is I want the letter is a state one. Okay, then you just write the letter and then send it. Okay, then after that, what you have done, the action is complete. You have said that you want to send the letter. Okay, now the receiver at the other end is received the certain things and says that okay, I have received your letter. Okay, that is the act state. Okay, that is the second state. So received state is this, sending state is one state and receiving state is another state. So these two actions are different kinds of actions that go on, and you have to switch from one state to another state. Once you have sent something and you have received something, then it means that the state is complete. The act for sending is complete. Then it say that it is called as state is complete. So you go on with the next state. Okay, you switch on to the next state. So you say action completed and you go to the next state. That is kind of thing. Okay, that is the finite state machine. So it is a kind of like machines which run on particular states of different kinds of information state. Mostly information is the basic thing of switching states. Okay, for a database or something like that. Okay, so you make a query on a particular database and finally it analyzes and then gives you a query answer, so yes or no, or it gives you the table or like then it is a finite state machine. The action is it's gone through different kinds of procedures, different kinds of states before it reached the final state. Okay, that's the final state. So you have to have an initial state and then a final state. That those are two kinds of action programs. Okay, you start with an initial state, you go to different states kind of thing, and finally you end up something like living and death and things like that. Okay, so you start from something that is kind of finite. So if you start from something and end in something, then it is called a finite state. If you start for something and never end, then it is called an infinite state machines. Okay, these are the basic concept of finite and infinite state machines. Okay, now if you want to go further on different kinds of states, each one of those states is called a pending state. So okay, there are different kinds of states: functional states, data states, and logic states. Okay, and network diagram states or vector states. These are different kinds of states are there. State machine is usually run for all kinds of programs. Any program you write or any neural network you write or any kind of network architecture you write, you usually start with state machines. State machines are very useful in analyzing a particular kind of logic or particular logic sequence and how things work, to understand how things work and how a machine, say you have you've written an algorithm, fuzzy logic algorithm or some kind of algorithm, and you want to make sure that it will work, those kind of things, the surety aspect is given by only these kinds of finite state machines. Okay, so unless you have reduced it to finite state machine, you cannot say that it is correct or wrong or something like that. So those are the kinds. So first thing you have to learn something about finite state machine. This is a very quite a bit of finite state machine. He has written a book and it gives you a complete structure of how the things work and other things. So you can go and have a look at it sometimes later and then find out what are the things it is in there and things like that. Okay, so this is the kind of diagram, state diagrams. This is called state diagrams. Okay, switching from one state to another state, another state to another state, and then if we have some kind of action, then coming back. Mostly people who design software designs and other things, they use these kind of states. Okay, network state kind of things. Okay, it analyzing a logic, this is the kind of things you have to do. Okay, whether you are analyzing a particular sequence of actions which you want to take, functional sequences or data sequences, all these things can be done by finite state machine. This is how we analyze a particular for a robot and other things. These are the finite state machine to go through. For language analysis, pattern recognition, these kind of finite state machines are very useful. So you have to go through this finite state machine and find out what are the things, and you can have a rough idea how these things work. Okay, it is a kind of thing which is applicable in any area, whether it is vector geometry or you kind of error correction in your computer program. All these things work on this kind of finite state machine. So you have to really thoroughly understand this finite state machines. Okay, this is for just for beginners and it's kind of like people who want to analyze certain things and kind of analyze and write. Okay, so any kind of analysis you want to do, this finite statement machine is very useful. So read something about these kind of things like how the logic sequence works, how vector diagrams work, all these things. So if you want to build a rocket, then you need this finite state kind of machine diagram. Okay, because the rocket can go any side, any direction. But if you have a finite state machine kind of direction, you are very sure that it will take this kind of path, this kind of trajectory, and it will work, and those logics will work properly. So if we not construct a machine or something like that, finite state machine and logic of those things have to be very thorough. Okay, how they work, how they switch state from one state to another state, how they finally arrive to the final state, initial state. What is the initial state? What is the second stage? What is the third state or third stage or something like that? So those kind of things are you have to learn all these things to find out. Okay, so this gives a complete for designing. Most of the design work is done on this kind of principles, finite state machines and other things. Okay, that's all for today. This is just about finite state machine, how AI works on finite state machines and other things. Thank you. Bye now.